Hi, I'm Michael Pfeiffer from Industrial Metallurgists. In this video, I'll talk about materials engineering for cost reduction. So in a previous video that I made for YouTube, it's called Turning Lead to Gold, and it talks about how materials and products can be engineered to help reduce the costs, in many cases by a lot. So taking a problem that's higher cost and turning a product into lower cost, so going from lead to gold. In this video, I'll talk a little more about that and materials engineering for cost reduction. Now, my discussion applies to all materials. I'm a metallurgical engineer, so I'll give examples related to metallurgy. So if you look at any product, it's composed of materials that have been manipulated and modified and shaped into different components, and those components are brought together to make a product. And we can engineer the materials that are used in the product to help reduce costs. And I will go through some different examples where we can do that. So the first opportunity for reducing cost is in over-designed products. This is situations where we have components that are using materials that are more expensive than necessary because they might have properties that are greater than we need, or um, or they have certain features or certain reliability that are greater than what's needed for the application. For example, using a stainless steel for a corrosion application when it might be possible to use a carbon steel with a zinc coating on it is one example of where it might be possible to reduce costs. Another example I have is a case where an alloy steel was being used, 4142. It was being specified and the material was being heat treated. But a 1045 steel would have sufficed for the application. And 1045 steel is much less expensive than a 4142. And they were purchasing a lot of the material to make a lot of components. So they ended up using 1045 for the application, and the components performed fine for the application, and 4142 was not needed any longer. Um, the in many cases, this re-engineering of components can be a fairly straightforward process. We're just looking at the requirements for the application and identifying what other materials might be possible to be used for that application. Another approach for reducing costs by engineering the materials used in products is by consolidation of materials across product lines, or even within a product where you have similar types of components, and rather than having them made of different materials, have them made all of the same material. And if you have similar components used across product lines, have them all made of the same materials, and maybe even try to have them made of the same dimensions as well, so you can buy in higher volumes and consolidate materials that are being used to be able to help reduce the cost through higher volumes, as well as being able to keep costs down due to having to manage less inventory. Then there's reducing manufacturing costs. Um, a lot of companies will sometimes design components and their suppliers have a hard time fabricating those components, and the costs associated with it, the hassle of fabricating the components, is passed on to the customer. Or it could be that someone is taking a material and they're fabricating components at their factory, and they're having problems with scrap, and they're having to throw components that they're producing because of issues with fabricating the components. So design for manufacturing, we think about the materials that are being used for the application, and are those materials easy to fabricate into the component? And if they're not, there's going to be costs associated with that, with the hassles associated with taking extra time to fabricate components, or costs associated with rework or even scrap. So as an example, I worked with a client who was forming tubing to form components to use in their product, and the tubing was occasionally splitting. And it turns out that the splits were occurring in materials that had higher carbon content. The higher carbon content was leading to spots in the tubing because the tubing was welded, and at the weld joint, the steel with the higher carbon content um, had higher hardness and less ductility, and the splits were occurring right at the weld joint. So we changed the material to a lower carbon content steel. It still met the strength requirements for the application, and the splitting problem went away, and there was over $100,000 scrap reduction per year savings associated with that minor change, as well as reducing the work in process associated with having to make extra components to deal with the scrap that was being produced. The final approach is to revisit existing designs. These are designs that may have been products that were developed years ago. People designed components not thinking too much about costs when costs were not as a big a focus as they are now. And revisiting the components and looking for opportunities to reduce the cost of the materials used in the components by engineering the materials used in the components, finding a less expensive material, or finding maybe a material that doesn't have to be heat treated, or a different coating that can be used on the material, something that will enable a less expensive material to be used for the component to have the same properties and reliability. And also, again, looking for ways to reduce costs by making components easier to fabricate so that suppliers have less hassles making components or there's less scrap. So there are a lot of ways for engineering the materials used in products to find ways to reduce costs. Why isn't everyone doing this? Well, people don't think about materials as a way of reducing costs. They focus on the form of the component. They're not metallurgists or materials engineers as well, and so they don't know all of the things that are available to help engineer the components and their products to come up with ways to reduce the cost. That's where involving a metallurgical engineer and a materials engineer can help out. There are many opportunities that might be available. I suggest maybe you start looking at that in your products and find ways to turn lead to gold. Thanks for watching. If you like this video, please subscribe to our channel. Also like the video and look for other things that are available on our channel and on our website. Thanks for watching. Good luck with your models. Bye.